Lawrence. I work for IBM Power North America team, specifically with, shockingly, open source databases. I'll try to keep it on pace. Wes is going to bring me on home like a third base coach if I take too long and bore you guys. So, quick show of hands. How many today? Oops, you'll do. Okay.
Well, a little louder, Bill.
A little louder? Okay, sorry. So how many today are doing anything with open source databases? Okay, that doesn't shock me. It's good. It leads me to my next slide. So if this works. There we go. So Gartner says by 2018, 70% of new application development will be on open source databases. And if you look at 50% of the existing relational databases, those will be targeted to be converted as well. And that will be open source databases as well as some of our new commercial kind of new technology databases. Connecticut will have a great spiel in just a little bit about some of their technology as well. As you can see, it's going to be changing a little bit from our traditional, I'm a DB2 shop, I'm a Oracle shop, it's going to be a changing environment. So let's talk a little bit about open source databases. So the Tokyo subway map over here, we'll talk about it. There won't be a test on this, don't worry. But what I did want to point out is, let's see if the pointer works here. Okay, so over here in this box is our traditional relational databases. You'll recognize some like Oracle and DB2, pretty common, especially Power customers. In here you'll see our open source ones listed with the blue font. And then over on this side, we'll have some of our non-relational databases, which we're going to talk about a little bit too. We'll talk some about some of the open source relational databases, but primarily we'll be talking about the NoSQL and some of the newer developments over on this side of the equation. So again, you don't have to memorize all that. Just kind of give you a lay of the land that it's more than just a few big players. There's a lot of activity in the database ecosystem. So you'll see up here, there's a lot of choices. And you'll find that not all your needs are going to be met by one database. You're going to find oftentimes you'll have a DB2 partnered with, say, MongoDB, or you'll have MongoDB and Connecticut or something partnered together to fit certain needs. You're not going to find one solution that's going to fill all your needs to where you're going to be just a monolithic database shop anymore. It's not going to just be a ton of work anymore. You'll have the relational databases that are still going to be around. It's a strong ecosystem. SQL, probably all of you today have large databases that run on a relational database. But you'll see on the NoSQL database, it's kind of this newer frontier. There's a lot you can do that can be a lot cheaper, potentially much better performance, and with the many different types, we'll talk about some of them. You'll be able to kind of answer these niche problems with the right tool. We'll talk a little bit about why some of this is, but the lower cost in particular is a lot of these are kind of like the Linux model. If you're familiar with Linux and how we'll give you Linux for free. Oh, if you want support, well, here comes Red Hat and we'll offer you support as SUSE. It's kind of the same thing in a lot of these open source databases. There's a community version for a lot of them where you can just download it, start testing, you're off to the races. If you want that kind of premium support where you pick up the phone and call them, well then that's where they kind of make a little bit of money, but still far cheaper than what Oracle or even IBM DB2 would charge you. So that's where a lot of the cost savings come from. And that can also aid some of your development too, when simply you can spin up some new instances and save a little bit of money, and not have to worry about waiting for that PO for some more licenses if you're exceeding your allocation pool, Oracle or DB2. It allows you to spin up new applications a little bit quicker and of course cheaper. So we'll talk about kind of these categories of the NoSQL databases. Next few slides will go into some in detail, but we have what's called a key value store. An example of that would be Redis, which we'll talk about. A document store, good example of that we see a lot of traction on, MongoDB. Common store like Cassandra that you'll see. And graph stores, which we'll talk about those, and there's a little picture I think will help understand the graph stores. It's kind of a different animal, but a common one we see is Neo4j graph stores. Okay, so again, I'm not going to cover too much time on the relational database. You guys are pretty familiar with that. Columns and tables, you've got your table joins, primary keys. You guys be pretty familiar with that. what I want to kind of go into a little bit more detail is like our document database, where, for example, Mongo, instead of storing in columns and tables, it stores as a file. There's an image in a minute that'll help tie this all home, I think. But you'll have where you have just a free-flowing document that stores all the data. The schema is pretty flexible, so it's not a rigid thing where you can add and subtract and do different things without having to redo the whole schema. And also a lot of times, and it happens with a lot of these, you're able to store a lot of data a little bit more efficiently because you don't have those rows where you have a lot of columns with null values and there's no data out there that takes up space even as null value. So you'll see that in a lot of these, that it simply can be space saving and with that some performance gains. The key value stores, a good example of that would be Redis. It's kind of a simple idea. Basically, you have an object, an item key, and it just has certain attributes. When you look up that key, it returns those attributes. Pretty free-flowing, particularly with Redis, because there's some things we'll talk about in a little bit as we break down specifically into these. Some real performance gains can be netted out from that. Wide column store, that's a little weird to my old relational database brain, but a good example of that is Cassandra. And it's where you can have these rows, but they don't have all the columns. Each row can have different columns in it. There's a diagram that may help you with that. That one blows my mind a little bit. But the nice thing about those is they scale really large and maintain very high performance, large scale. Graph databases, and this is one where I think the upcoming image will help a little bit too. So they just kind of, they help uncover the relationships you have between your data. They kind of treat your data as nodes that'll have certain attributes, and then you work to show the relationships between these items. Could be, social networking, could be fraud detection. We'll go into deep detail on that somewhat, and I think there's an image that'll help kind of figure out what's going on there, because the graph database is a little different animal. It's kind of like how you would store data if you drew it up on a whiteboard. Okay, so some of those images. In the middle, we have the traditional relational database. I mean, you should recognize this, primary key reference over to this other table, columns and tables. Up at the document side, so this is MongoDB as an example. So you have this file, or this document that has these attributes, and it's whatever you want within your schema. It's pretty flexible. You don't have to store a whole bunch of null values. It's nice and tidy. Just keep it as you want. Over on the key value side, this is the one where you'll have, like, again, that item, that document, whatever it is, references with just these attributes. You call up, whatever that particular key is, retrieve those attributes. It's pretty simple. It's a pretty tidy way to store the data. We'll show you some use cases for these two that kind of help figure out where they kind of play. Here's that Cassandra example I gave you with wide column store. I hope this makes more sense to you than it does me. This one kind of blows my mind about having columns and rows, but not all the rows have the same columns. The thing to take away from Cassandra, we'll talk about in a little detail, is that it can scale very big, very high performance. And then the graph model, which hopefully you guys can see okay over here. I realize it's a little tiny. In this example, you'll have like, the owner of this Twitter handle here. He owns this type of car. It has to be a Volvo. He loves, married. All this kind of social. In this example, it's more of a social media one to try to get details out of the data. There's also a lot of stuff with fraud detection where you kind of check to see where things don't make sense relationally. That kicks out problems. But I think the graph at least helps explain a little bit. It's really kind of storing data almost like you would diagram it on a whiteboard, and it presents a lot of the data graphically back to you too, which can be interesting. Okay, so we'll talk a little bit here, and we're going to break down into these a little bit more detail. I just like to have this nice kind of tidy list for you all. So again, MongoDB, that's your document store. Really just to go to some of these use cases. These will give you a single view of the customer records, content management, catalogs, personalization, all stored in those documents. For Redis, this one's interesting because it's an in-memory store. So we'll talk a little bit about Cappy in a minute. Hopefully it'll make sense to you all in a few. But Redis can store primarily running out of in-memory. So a lot of things that are going to be very dynamic, quick response time, data queues, user session data, shopping cart data, videos. There's a lot you can do with that. It's interesting and it's fast. Cassandra, again, I'll talk about that, the column store. It's a NoSQL environment, very high scale, very high reliability. Oftentimes you'll see that used for messaging, fraud detection, Internet of Things data where you're getting a lot of sensor data coming in from different sources. It's a common place to see in telco too. Neo4j, which was that graph store I talked about, it stores that data as edges, nodes. Kind of, I like nodes personally as a reference that. But again, that's another one that's good for fraud detection, social networking. You'll see location-aware apps. Machine learning is another one. So as we go through this, you'll see that they kind of have different attributes. They'll have different areas to play. Oftentimes there's overlap. And if you talk to Redis, I'm sure they can say they can do everything. If you talk to Mongo, they'll tell you they can do everything. But they do tend to have some more sweet spots. And when we go a little bit deeper into these, we'll have some use cases that will help. Postgres or Enterprise DB, I want to talk about this one a little bit. So Postgres is the community version. Enterprise DB is the supported version, kind of like the Red Hat to Linux idea. So this one is more of a traditional relational database, much like Oracle. In fact, it has a lot of compatibility with Oracle. We'll talk about that in just a few. But again, this is more of your open source. If you want a relational database, it's kind of more traditionally what you're used to, and it's that mode. A lot of the big use cases we see for is simply customers that are maybe a little tired of Oracle pricing, or they're growing rapidly and don't want to have to up that next end user license agreement type of thing, or enterprise license. Enterprise licensing. We see a lot of take up there. So we'll dive deeper into that, of course. And MariaDB, which is another open source relational database. This one's kind of like where when Oracle got MySQL, this was kind of a fork. So people weren't necessarily happy that Oracle took over MySQL, so MariaDB was kind of the answer to that. So you see that around MySQL, triple LAMP stack type of activities. Okay, so we're going to dive just a little bit deeper. I'm not going to try to go too into the weeds for you, if I haven't bored you to death yet. So Redis. So with Redis, again, this is an in-memory one, so it's pretty fast. I mean, it's amazingly fast with that kind of simple key structure. You just get the key, you get the attributes back for it. One of the exploits I want to talk about here is that it uses a power-only capability called CAPI, in this particular case, CAPI Flash. So I'm going to ask, show of hands, how many people are aware of CAPI? Okay, I'm glad you are. Okay, so CAPI is basically, you can think of it as, there's a PCI card that you put in your Power 8 box, and then with that, in a CAPI Flash scenario, you attach one of our flash units that has a bunch of memory DIMMs in there. And then the system basically sees that as extended memory. So in some of these examples, you'll see where it references, say, 56 terabytes of memory in one power box. It's very nice for in-memory database performance, to have that kind of memory. And because the way that CAPI is structured, and Wes, I can't remember if you have a slide on this or not, but it simplifies it so you're not writing a lot of application code to deal with it. It really masks a lot of the code for it. So it's a pretty neat technology. You'll see with not only Redis, but some of the other ones, they're leveraging CAPI as well. So again, some of the features, master-slave replication, automatic failover. I kind of like these little items about best use, rapidly changing data, and with a foreseeable database size, because again, it is in memory. If this is something that's going to scale way up and down, it may not be the best fit unless you have a lot of memory. As long as you kind of have an idea what that memory footprint will be, what that database size will be, Redis can make a lot of sense there, especially for performance. And then some of the examples, store real-time stock prices, real-time analytics, communication with Memcache before would have been used. So MongoDB. So again, MongoDB is kind of nice because it does have some SQL capabilities, that query and index, so there's some commonality there if that's your developers, if that's where the heart lies. Again, just like Redis, MongoDB has some CAPI Flash capability they're testing. It should be available soon. So again, potentially extend that memory far out beyond just the physical DIMMs during the server and use that for performance. Again, master-slave, replication kind of, see this, sharding if you need to go across many different servers. Now, if some of you all have some large enterprise class boxes that are very resilient, you might just run it all in that box, or replicate it across. But you could shard it across a bunch of smaller scale-out power boxes where it'll have a piece of the database across there. And with that, it can be data center or where to where. You can locate that data where it needs to be, and also if there's failover, there's some things they can do about that. So it's the right data center answers the call with that sharding. So one of the uses is use dynamic queries. If you prefer defined indexes, not so much map-reduce functions. If you need good performance on BigDB, and then if you wanted couch DB but your data changes too much filling up disk, then Mongo also makes sense. It is the most popular NoSQL document database out there, and we do see a lot of customers using it. Okay, Cassandra, just want to kind of works my brain a little bit, so bear with me. So I won't read all this and put you all completely to sleep. But it is, main point is to store huge data sets. It really scales up. You can do some kind of similar SQL type activities, but there's some things with it, like it can't do joins. So it's kind of some SQL, not so much some other. Again, the main thing, if you talk about Cassandra, that highly scalable, highly available. We talk really scale up. One of the other items I like to point out is just a flexible schema. Again, you're getting, with these, typically you're getting a lot more flexible schema than a relational database where you're really got to put that all out, and then changes are difficult. It's much more flexible. I can do some things directly with Hadoop. We'll talk about a couple of Hadoop things that would tail into this. But best used when you need to store huge data sets that don't fit on the server. And it does have some interfaces to kind of make management easy for that. So it's not just that it can scale, but it can be easily managed. Web analytics, count hits by the hour, browser transaction logging, data collection from huge sense array. If you've got a lot of stuff out in the field that's giving you data streaming on in, Cassandra makes a lot of sense there. Okay, Neo4j, that's the graphical one again, that kind of whiteboard scenario. It's a graph database optimized for connected data. They have that capping capability to do the, in this example, 56 terabytes of extended memory. The main thing to really take away from it is that it is that graphical storage, graphically presents results as well. It is full ACID capability, so you know that the data is stored, it is what it is. And it rolls back if it doesn't get put in there directly. It does have its own query language, Cipher, which apparently is very easy to use. I haven't had keyboard time with it, but I've heard great things about it. One of the main things it does is just indexing the keys, nodes, and relationships. So don't confuse it with a relational database, but it's very great at showing graphically relationships between items. It's kind of optimized for reads versus writes. Really, it's best used for graph-style, rich, complex, interconnected data, like social media kind of stuff. You can obviously see it play there. Public transport links, roadmaps, network topologies, anything kind of has that relational kind of view of it. Very interesting. Okay, so Enterprise DB, this isn't a NoSQL, this is more a traditional relational database, but it's open source. So again, it's an enterprise class, open source relational database. It very easily integrates into an Oracle DB shop. Show of hands, how many are primarily Oracle? Okay, good few. The rest DB2 or other? Okay, all right. I like it. So if you're an Oracle shop where Enterprise DB or the community version is Postgres, again, think of this as that Linux scenario. Postgres is the community version, Enterprise DB is the Red Hat supported. Pick up the phone, call them for support version. But it integrates very tightly with Oracle. You're probably not going to do a rip and replace it, like tomorrow change out all your Oracle databases with Enterprise DB. I'm sure hardware sellers would love that, but what you're going to do is probably around the edge. What we often see is new app development, and again, it goes back to that 70% of new app development common up front. A lot of the new apps will be written in Enterprise DB. They work very well with the Oracle applications that exist today. In fact, Enterprise DB has a tool where they can look at your Oracle applications and test to see are they fully compatible out of the gate, or there's some little tweaks or something that may be specific to Oracle. So they can do that for you to see where that might easily be ported over. So typically around the edge, you'll start introducing new apps. You'll just leverage the Enterprise DB relational database. Works very nicely with the Oracle applications you have today. Why you might do that is it's a lot cheaper. So you're not paying for the software, and then the support angle is still significantly cheaper than what you would get with, say, Oracle, for example. So again, scalable. I mean, this is a relational database just like in any others. Multi-terabyte data sets, millions of users, transactional integrity, all that stuff you've grown to know and love from your relational database. So there are some things, and I'll caution here just a little bit because it does more than just relational database. It does some NoSQL kind of functions, some other bells and whistles. I would think it's best to think of that as if the mainstay is relational databases and you want some of those bells and whistles, that makes a lot of sense. If you're primarily want to do a lot of NoSQL stuff, then probably one of the other solutions might make more sense for that effort. And then again, the services side, Enterprise DB, they support any of the big enterprise customers just the same way you would if you pick up the phone for a DB2 problem or an Oracle problem. And it's open source. So I won't bore you with like the whole TCO stuff and all that. I just want 2 slides. I know we kind of sometimes get way off the weeds on this stuff, but I wanted to give an example. I'll have the Mongo one next and EDB. So in this scenario, we're comparing Power with EDB versus x86 and Oracle. So in this scenario, we're able to do 30% less servers, 84% reduction in software licensing with fewer cores and Enterprise DB. You have 29% reduction in hardware costs versus the x86 side, and a 68% reduction in core count in this scenario. And that is not just the, say, Oracle in this example or EDB, but any of your drag along if you have supporting applications or anything else that rides on those, has some per core licensing. That helps you there too. So in this scenario, comparing these 2 boxes, an SA22LC and the HDDL 380P with the Broadwell, that shows a 79% reduction in TCO. So if you're like me, you kind of come from the nerd side of the background. I know this sometimes is boring, but this is the nice justification when you need to go forward and talk the lines of business, the management to justify some of these things. You can see huge returns with the open source database and leveraging Power to help enhance that. MongoDB example is very similar. Again, this is MongoDB on Power versus Oracle on x86. So you see a 90% reduction in software licensing with fewer cores, 23% reduction in hardware costs and maintenance, 45% reduction in core counts. And this one in this example, and again, it's the same kind of server comparison, 85% reduction for your TCO. So these are substantial numbers. I mean, it's not one of those where it's a little thin one and you kind of have to bring it on home. I mean, these are huge differences. Okay, so I want to talk just briefly about Hortonworks. I realize it's not an open source database per se, but it is an open source Hadoop product that oftentimes interfaces with a lot of our open source databases. But at the Edge conference, I don't know if anybody was able to attend the Edge conference out in Vegas this year. But Hortonworks announced that it's coming on Power. So we have some initial customers right now as part of the pilot program. If you're, I don't know how many people are familiar with it or not, but it's the new product. And they have, Hortonworks was founded with the original architects from Yahoo that came up with Hadoop. So they're kind of one of the big boys in the Hadoop space. They now support Power. They're one of the big players in the market. I don't know if anybody has any Hadoop products in the work, projects in the work or not. So I don't know if you're using Hortonworks or whatever today, and maybe on x86 or Hadoop on Power with some open source version. But it is an open source, fully supported, production ready Hadoop product. We're really glad to have them aboard. Very, very large interest in the market. I just want to bring it on back. Hopefully I didn't throw Wes off too badly here. But again, I just wanted to point that out. Again, Gartner's saying 2018, 70% of that new application development is going to be on open source database. And 50% of your existing relational database, DB2, Oracle, what have you, they expect to be being converted to open source or some of the newer technology. It's not to say that commercial technology won't still have a role to play. There's some very unique commercial products. Kinetica is one of them you'll hear about here in a few, with some really neat and interesting plays. But you can see the world's changing a little bit. So I'd just like to end on this note, and I guess I will bring it on home for Wes. Thank you.